right, let's look at our parent functions on this second video here. So we've already talked about all the properties. So let's keep going here to our first one. So what you'll want to do, I think we are just going to do 12 basic functions. What you want to have for this one is this document that is on Schoology. So go ahead and print that out, and we'll just kind of go through each of these parent functions and talk about all of the different properties that we discussed in the last video. All right, so we are going to look at a couple of key points. Some of these graphs we're going to do transformations on as we progress through this chapter. So there are some key points that I do want you to have written in there. So for the identity function, which is, I think I have named linear, a linear function on that sheet. We're going to look at, it's just a line y equals mx plus b, and it's just a line with slope 1, going through 0, 0. So our three key points are going to be -1, -1, 0, 0, and 1, 1. And we're going to use those points when we do some transformations. But the equation looks like this. It's essentially y equals x. I have f of x equals x, just so you know it is a function. And it's just, it passes a vertical line test. So. All right, there's an interesting fact about it. Not really, but there it is. All right, so if we go to this sheet here and we look at the linear function and the domain, so the domain should be all reals. I can actually just kind of, so you'll be looking at this and I'll be looking at my slides. So here the domain, you can see x values for the domain can be any number because there's going to be a corresponding y part to it on the graph. So all reals for the domain. The range, it goes all the way high and all the way low. So it goes to infinity, negative infinity. So that again is all reals. And when we say all reals, this is how we write them in interval notation. So there's your domain. Oops. And your range will be the same. Again, if infinity, it never hits infinity. And so it's going to be open at that location. All right. Let's see what else is on there. Continuous. It is continuous. Symmetry. There's a rotational symmetry. So it's going to be odd. It's going to have an odd symmetry. There is no extrema because it goes to the y values go to infinity. And so there's no max or min. There's no asymptotes. And let's see, so increasing, it looks like this one is increasing all throughout the whole domain. And so remember, increasing is an interval. So it increases from negative infinity to infinity. Again, intervals are always on the axis. There's no decreasing area. And end behavior. So that's the one we'll look at here a little bit more thoroughly. So the end behavior, we have the limit as x. It goes right under the word limit. X approaches infinity of f of x. And then we also have the limit as x approaches negative infinity of f of x. So basically what this is looking for is what is happening to the y values as x gets larger or smaller. The only thing kind of lower is this x approaches. So, all right, so as x gets bigger, you can see the values on the graph of the y values gets bigger, so that's infinity. And as x gets smaller, the y values get smaller and smaller, so negative infinity. Okay, so that one should be all filled in. All right, our next one is going to be the squaring function, or the quadratic. I think I call it quadratic on yours. All right, that's what it looks like. The key points we're going to look at are going to be these three, and we'll use these for transformations. -1, 1, 0, 0, and 1, 1. Okay. Okay, so I'm going to have you pause the video, and I want you to try to fill in the domain, the range, the continuous or not, increasing, decreasing intervals, symmetry, is it bounded, is there extremas, that means minimum or max, are there asymptotes, and end behavior. So pause the video, fill those in, and then come back and we will fill them in. And we're back. Okay, so our domain here, it's what values of x are going to be on the graph. So if you think about all these coordinates of these points, it keeps the x's going both directions. So you can have any x value. So negative infinity to infinity. The range is only going to start, the y values on the graph are going to start from 0 and then just get bigger, right? Every y value just keeps getting bigger. So that the 0 is included, so we'll square that one off. It is continuous. All right. It has a even symmetry because it's reflected over the y-axis. It is bounded below because we can draw a horizontal line underneath it and it never touches a graph. I forgot to do that one on the last one. The last one is not bounded. There are no asymptotes. There is an extrema. There is a minimum, and then the minimum is 0. Typically, for a minimum, we're looking for the y value. So a minimum at x equals 0 of 0, right? So this is the y value. Let's see what else is there. Increasing and decreasing. So we'll do our increasing piece first. So our increasing piece starts from 0 and it continues on. And again, it's an interval. So it's going to start from 0 and go to infinity. We'll include the endpoints. Decreasing is going to be this side of the graph. So again, negative infinity to 0, not including negative infinity, including 0. Remember that the order is the same order you would see it on a number line, right? Because negative infinity is out here. So that would go before the 0, as would the 0 would go before the infinity. And the last thing we have is end behavior. And so our end behavior is the limit as x approaches infinity of this function. So this says what's happening as x gets bigger on the graph, my graph is going up. So the y values are going up to infinity. And as x approaches negative infinity, that also goes up and gets bigger. So positive infinity again. Okay. I'm not sure if this is going to go in the same order of what's on your sheet. Let's see what's next on your sheet. The absolute value. We'll go ahead and skip to that one. It's down a little ways. I think I rearranged the orders here. Here we go. So absolute value, we're going to look at our key points again. This really looks like a U, except it's a V-shaped. It's going to be the same 3 points that we're going to use for transformations, negative 1, 1, 0, 0, and 1, 1. All right. Really, if you think about this as it relates to the quadratic, everything's the same. And behavior is the same. Continuous is the same. Increasing, decreasing is the same. It has just a slightly different shape. But all of the properties for an absolute value are essentially the same properties of a quadratic. Even the points, it's just that the quadratic increases for the y's a little bit faster than this one. This one just kind of goes, the slope is 1, and then the other one just kind of increases a little steeper. All right, but all the properties are the same. So you can go ahead and fill those in from your last one. Let's see what's next on the sheet. Cubic, all right. So let's go to the cubic one. All right, here we go. All right, so the cubic, some people call this a lane change. I don't know. That's just a cubic for me. We're going to use the 3 points. The same 3 points we used for linear. Negative 1, negative 1. 0, 0, 1, 1. We'll use those for transformation purposes later. Okay, so domain and range should be the same as linear, right? So the domain is negative infinity to infinity because it encompasses every single one of the x values. This goes bigger and bigger and bigger and bigger and bigger, but it doesn't look like it because it starts to go less of a or more of a steep slant each time, but the domain and the range are negative infinity to infinity. And again, it encompasses every x and every y value on here eventually. It's continuous, right? It is not bounded because you can't draw a line. Why don't you fill the rest in and we'll come back and pause the video and then come back and we'll check it. Okay, and we're back. So symmetry is an odd symmetry. Again, we said it's not bounded. There is no extrema. There's no high or low point. There's a turning point, but it's not a high or low point. There's no asymptotes. It's increasing on its entire domain, so it increases from negative infinity to infinity. And then our end behaviors. So we'll just do our end behaviors here. The limit, as x approaches infinity. So as x gets bigger, the y is getting bigger. And then we'll do the other one. As x gets smaller, as it approaches negative infinity, you can see the graph is going downwards, so the y values approach negative infinity. Okay. I think the next one is our square root, and I put the square root underneath the squared for a reason. So that's kind of, I was doing some rearranging of these little boxes. So again, the square root is under the squared for a reason. And let's go back here and do the square root one. Here we go. So the key points on the square root. Really, a lot of kids struggle with this one, and it's really super easy. If you think about the square root function, what happens if we put 0 in for x? What do we get out? That's right, we get a 0 out. What happens when we put 1 in for x? What do we get out? You're right again. And then the next one we would put in for x that would give us a nice value out would be 4, right? Square root of 4 is 2. We could use 9 and 3, but these are the 3 points we're going to go ahead and, for transformation ppurposes, when we get there, out here at 9, it'll be up at 3, but we'll use those 3 general points for that. Okay, so, this is an interesting fact, so let's read it. Put any positive number in your calculator and keep taking the square root. Eventually, you're going to get to 1. What? Try it. Okay, I'm going to have you go ahead and pause the video, fill in your domain and your range, and all of the rest of the things on there, and then come on back and we'll do it. And we're back. So our domain on this case, my x values start at 0 and go positive. So start at 0 and just get bigger. We'll include that 0 because it's on the graph. The range is exactly the same thing. The y values, how far up does it go? Even though it goes up really slowly, it is going to hit every y value. So from 0 to infinity. It is continuous. It is increasing on its entire domain. So the entire domain, it increases. There is a minimum at x equals 0 of 0. There are no asymptotes. It is bounded below. Kind of doing these in a weird order. There is no symmetry. Remember, symmetry is either reflected over the y-axis for even or rotational symmetry of 180 degrees for odd. So there's no symmetry here. And we have end behavior. So the end behavior, so the limit as x approaches infinity. So as x gets larger, my y values are getting bigger and bigger and bigger. So infinity. Now, here's a weird thing. There is no other end behavior. There's only one end to the graph, the one that's going out in this direction. If you try to look at what's the end behavior over here, it never goes out in that direction. It just stops. So this scenario, there's only one end behavior. Now, I put this one under the squaring function because these two, squared and square root, they're inverses, and we'll talk about inverses later in the chapter, and you've done inverses before, but the graphs kind of look the same. We look at our squaring, except not all of the graph is included. So here, just part of the graph. We'll use this part is included on the square rooting because you can only square root positive numbers, so there's no negative portion to it. We'll talk more about the inverse functions there later in the chapter. Let's see what I have next. I think maybe reciprocal. So the reciprocal function is 1 over x. Let's look at that one. Where is that one? That one's right here. This is what the reciprocal function looks like. It's also known as a hyperbola. But we have no key points on here. We're not even going to worry about like 1. I guess you could do 1, 1. You could do these 2 points, but really what we're looking at are our asymptotes. So there are asymptotes. We might as well say -1, and our asymptotes. So our asymptote is the y-axis, which is the equation x equals 0, right? Because everywhere on that asymptote, the x value is 0. And then we have our other asymptote, which is this one, x-axis. The equation of the x-axis is y equals 0, right? Every point on here has a y value of 0. So if you're trying to get, what are the asymptote equations, because I'll always ask for them as an equation of a line, because they are lines, you'll have to write those properly. Okay, so that's what that one looks like. Go ahead and pause the video, fill in all of the properties, and we'll be right back to do that. Okay, our domain this time, if you notice, our domain or x values can be anything except for that asymptote value of 0. And so essentially it's the whole number line, really, except for 0. So it's everything over here and everything over here. So essentially it's -infinity all the way up to 0, but not including 0, and then 0 to infinity. We put a little u in here because that just stands for union. It could be any of those values in that domain. The range is exactly the same because the same goes for this x-axis. The values of y can be anything except for that x-axis value. So -infinity to 0, 0 to infinity. Not including the 0 because that's the asymptote. It is not continuous. There is a jump discontinuity. There's no holes, but it's discontinuous. It's a jump discontinuity. It is not bounded above or below because it has to, if we draw a line above, it never hits the entire graph, and here it would. If I draw a line below, it would still hit the graph. So it's not bounded. There's no extrema because the y values just keep getting smaller or larger. The asymptotes we have written, and then the end behavior. Oh, and then the symmetry is odd because it's rotational. If we rotated this 180 degrees, we would get down to that blue portion of the graph. All right, so the limit as x approaches infinity of f of x is, so as x gets bigger, what's happening to my graph values? My y values on the graph gets closer and closer to 0. So this is something we haven't seen before, but as x gets bigger, y is getting closer and closer to 0, and that's what it's approaching. So this is always as x approaches infinity, what is it getting closer to? And the next one is x approaches -infinity. So that's this one. So as x gets smaller out here, that's going this way on the graph. And again, that graph is getting closer and closer to the axis, and the value at the axis is 0. So that is the end behavior of the hyperbola or reciprocal functions. Now, there's a couple different reciprocal functions you've worked with hyperbolas in the past. This is the 1 over x one. I wonder if it might be a good idea for you to put these on there as well. So here's the negative. F of x equals 1 over -x. That just flips the quadrants. You have the same x and y asymptotes. You have the same domain in the ranges. Everything is the same on these, right? For these two, all the properties are exactly the same. It still has rotational symmetry around 0, around the origin. The end behaviors change a little bit, right? No, they don't. They actually stay the same because as x gets bigger, y gets closer to 0. As x gets smaller, y gets closer to 0. Right, then we have 1 over x squared. What that does is it makes any x that you have that might be negative, like this one, and it makes it positive, so it brings it up to quadrant 2. Or if I have -1 over x squared, that brings them both down to quadrant, the lower quadrants 3 and 4. And behaviors, again, still the same. Here, what's going to change from these ones up here is your range will change, and it will become from 0 to infinity. The domain is still all reals except for 0, but the range is going to be from 0 to infinity. Here, the range will change. It's going to be from 0 and then go down to -infinity. Remember which one goes first? The -infinity goes first because on a number line, it's further to the left. Okay, but otherwise all the properties are the same. These do not have a rotational symmetry. These have a even symmetry, and these are odd. But otherwise, asymptotes are the same and behavior is the same. So I would get those written on your little note sheet too, if you can squeeze them underneath there somewhere or on the side. All right, next thing on here is, next page, the natural log function. I put that right next to the exponential function because those are also inverses of each other. We deal with these two in chapter 3, I think it is. We look at those a little bit more thoroughly. And this one down here, the logistic, that's going to be a chapter 3 one as well. And then the sine and cosine we'll look at in chapter 6, I think. And semicircle we just threw in there because it's something that the calc teachers have asked us to kind of cover briefly. So they've actually seen it before. So we'll talk about that in a minute. But for now, let's go to the natural log function. So here's our natural log function. Key points are going to be 1 point, this point right here. So it always passes through the point 1, 0. And the asymptote for transformation purposes is the y-axis, which is the equation x equals 0. Okay, so the natural log, if you try to put in the natural log of 1, you get 0 all the time, no matter what. And so that's why that's the point. And then the asymptote is right here because you cannot natural log any negative number. So if we tried natural log -5, you would get an error on your calculator, which we don't really use calculators in here that much. So, okay, so those are the key points for transformation purposes. Why don't you go ahead and fill in what you think all the properties are and come on back. And we're back. Our domain goes from 0 to infinity, right? From 0 to infinity, not including 0 because there's an asymptote there. I might as well just write that asymptote down right here. That is the, oh, there it is, asymptote. X equals 0. The range, however, it keeps going, keeps getting bigger and bigger and bigger and bigger and bigger. So it goes from negative infinity down here to positive infinity. So all real numbers. It is continuous. It is not bounded because it keeps going up and down the y values. There's no symmetry. There's no extrema. We have 1 end behavior because x doesn't go toward the negative infinity. X goes only toward positive infinity. So it's the same as that square root one. There's no negative infinity out here. There's no negative portion to the graph. And let's see. Oh, it increases on the entire domain. So I'll just kind of throw that right in here. I think I forgot to do increasing, decreasing on the reciprocal. Let me go back and find that one. And let's get that filled in here. Oh, what a mess. Over here. Okay, so increasing. Let's look. So as I look from left to right, this one's going down. And from left to right, if I trace the graph, that one's also going down. So nope, it never increases. It only decreases here. So, and it's decreasing, remember these are intervals. So from way out here down to way down here, these are x coordinates. So from negative infinity up to 0, it's decreasing. But then it stops and it doesn't include 0 because there's an asymptote there. And then it kind of pops over the 0. And so from 0 all the way to infinity, it also is decreasing. So that decreases on its entire domain, it would be called words. All right, so let's see what we got here. Exponential is next. Exponential, there is an asymptote. So we're going to use that asymptote. And that is at the x-axis, which the equation of the x-axis is all the y's are a value of 0. Every coordinate has a y value of 0. The key points right here, it's going to be 0, 1. Notice it's kind of the flipped of this one. The natural log and the exponential are inverses of each other, so that's what flips, right? Y equals 0, here it was x equals 0. 0, 1, 1, 0. So kind of a flippity-doo. We're using e to the x power. One thing about exponentials, x is in the exponent. Some kids see x squared and think it's an exponential, and it's not. There's no x in the exponent. X to the third, that's not exponential. That's a cubic. There's no x in the exponent. So exponentials always have an x in the exponent. All right, so go ahead and fill in the properties. Pause the video and come back. All right, our domain, all reals. All right, because it continues, it goes forever in both directions, right and left. Our range is limited. It's like the square root one. It's going to start at 0 but not include 0 and just go up, right? That's what the y values can be on this graph, from 0 to infinity, not including the 0. It is continuous. We have the asymptote. It is bounded below and bounded below with the asymptote. Let's see. It's increasing on its entire domain. So from left to right, it continually goes up. So I'll just kind of put that in there too, because I'm lazy. Let's see, symmetry, no extremas. Well, I guess it doesn't actually hit 0. This approaches it. So I don't really like to say that there's an extrema since it never hits 0. It does have some end behavior. That's supposed to say end. Wow. All right, I'm going to erase that word end and write it so you can read it. You can kind of read behavior. Okay, so the limit as x approaches infinity. So as x gets bigger, hopefully you get this right by now, it's going upward. The y value is going upward. So that's infinity. The limit as x approaches negative infinity, it does approach negative infinity. What's happening to the y values? It's getting closer and closer to 0. Okay. So sometimes kids get in the habit of saying, hey, it's either infinity or negative infinity or zeros and zeros, but it's not. Sometimes it's a mixture of the two. All right, so yeah. Okay, and everything else? I think I got everything else on there. Oh, increasing, oh, I did that. And no symmetry. Okay, good. All right, let's jump to sine. So, chapter 4, this is when we do the sine and the cosine. So we are not going to do any transformations on these. So just know that it kind of looks like this, curvy, curvy, wavy, wavy. Try to identify the properties here and then come on back. And we're back. Domain. Our x values can be anything, right? From negative infinity to infinity. There's a point everywhere. Every x value has a point on the graph associated with the graph. The range, though, it looks like it's the high point. It goes from there down to here. And so it looks like it goes from -1 to 1. So that is our range, and it's including the 1 and the -1. Those are our minimums and our maximums as well. So this time we do have extremas, a min and a max. So we'll just say a max of 1 and a max of -1. And it happens several times, so I'm not going to actually say where it's occurring. Just say that the maximum is 1 and the minimum value is -1. It's bounded above and below. I'll just say both, so we can draw our lines in there. There's no asymptotes. There's a rotational symmetry, so it's odd. We said continuous. It's increasing and decreasing in an increment. So let's just kind of look at that. It's hard to say on this one particular because there's so many different locations that it increases and decreases. So you can see here, like from here to here, it's increasing, and then it starts to decrease, and then it increases again, then it decreases. So we'll just kind of leave that one. Yeah, we'll just kind of leave that one. We won't put anything increasing and decreasing because there's too many different intervals there that it would happen. So just cross those increasing and decreasing out on this one. The end behavior, there isn't any because as x gets bigger, this continually goes, is it up, is it down, is it up, is it down, is it up, is it down? So it doesn't approach anything. So there's no end behavior. And that's about it. Our cosine function's pretty much the same. Everything's the same, but so maximum is the same, minimum is the same, no end behavior, bounded above and below, no asymptotes. What happened to my 2 and my 4? I don't know. That's weird. What does, and the range is the same, the domain is the same. Yeah, pretty much everything's the same. The only difference is like where the high and low point are occurring, but we won't worry about that until chapter 4. We are going to do transformations on these two graphs, but not until chapter 4. All right, the last graph that, there's actually another one in here that is in our textbook, the greatest integer function. We're not going to do that because we don't ever see that again the entire year. So we're just going to kind of skip it. I think you might have looked at this in advanced algebra. Here's like a word problem application example of this. Let's say it's, well, not this part of the graph, but let's say you go into a parking lot ramp and for the first hour, this is how much you pay. And then the second hour, it goes up to this amount all the way up to hour 3. And then when it's up at hour 3, it jumps up to this dollar amount, which is not accurate at all because I was just at the Hennepin County Center downtown Minneapolis, and I was there for like an hour and a half and had to pay $36. Sorry, I just had to get that out. $36 for an hour and a half parking. All right. Okay, I'm past it though. Logistic function. Oh, I guess we do have another one. Logistic function, we're going to do this in chapter 3, but just try to identify the properties here. You notice there is an asymptote up here. The asymptote is at y equals 1. Also, there's another asymptote right here. See how it approaches? So at y equals 0. The domain is all reals. The range goes from 0 to 1. It doesn't include either of them because they're asymptotes. It's continuous. It does not have any symmetry because it's not about the origin. It's bounded above and below by those two asymptotes. It's increasing on the entire domain. There's no decreasing area. The end behavior, this one's interesting. So the limit as x approaches infinity of this function. Notice how as x gets bigger, the values of y get closer and closer to 1. Okay? It doesn't have to hit 1. It's just a limit. What does it approach? And then I'll put the other one over here. The limit as x approaches negative infinity. Well, you can see as x gets smaller, the graph is getting closer and closer to 0. All right. Okay, so now the semicircle one. So I'm assuming you all know that this is the equation of a circle, right? So like if you had x squared plus y squared equals 9, and you were to graph that circle, it would go out, this stands for r squared, it would go out 3 in each direction. We will be looking at this a little bit more thoroughly in chapter 8, graphing what's called conic sections, but that's what a circle equation looks like. X squared plus y squared equals the radius squared. All right. A semicircle is used quite often in calculus. You encounter it. And so basically what they did was I took this equation and they solved it for y. When you solve it for y, you move the x squared over, so it's r squared minus x squared. And then since that's y squared, we would square root it. And when we square root it, we get a plus and a minus. Okay, the top portion is the plus. When we square root something, we get plus or minus. So we would also have this, and that would be the bottom portion. But that's not a semicircle, that's the circle. So we're not really concerned about that. Just the top portion here is what we're concerned with. So this is what the equation of a semicircle looks like. Okay, with this being the value of r, that's the radius, how far away it is from 0 or from the center of the circle. So in the scenario, something like this, if it was x squared plus y squared is 25, where these would all be 5, it would be the r squared minus x squared. The square root of that would be the semicircle, the blue equation. Okay. So let's go ahead and identify. I'm just going to take this portion off. We're going to go ahead and identify all our pieces. So our domain would be from, in this scenario, -5 to 5, but we want it for all semicircles. So it's essentially from the negative radius to the radius. And it hits those points, right? So if it was this one, it would be from -5 to 5, but it's just a general radius one. This is an R, by the way. Okay. The range goes from 0 up to 5 in the numerical example, but really up to R in the other example. And it would include 0 because you can see there are points where y equals 0 all the way up to y equals 5. It's continuous, it's bounded below, there's an extrema, so the minimum of 0 at R and at x equals R and x equals -R, and a maximum of R at x equals 0, right? So at x equals 0, it's a maximum point of 5, and at x equals 5, there's a minimum point of 0, and the same over here with negative. Increasing, it does increase here from this point to 0, so from -R to 0, and decreases from 0 to R. And again, we include the endpoints on this. And no asymptotes, no end behavior because it just kind of stops. And it's an even symmetry because it's flipped over the y-axis. Okay, so hopefully you have that whole sheet filled in. And all right, so then we did all of these. And so let's see, we're going to go to the very end here, and you are going to do your assignment number 1. And let's see on Schoology, let me find the Schoology page. So if you look at lesson 1, this was on graphing properties and parent functions. And I have the assignment listed here. It should probably also be in a calendar. And I think I have an assignment chart on here as well. Assignments, lectures, and textbook. So here's the assignment chart if you ever want to look it up. But I'll try to put them in little folders and try to keep them organized for you. So you can just look in this folder. And then, so you'll do this one. Basically, it's just a few problems from page 102. I did put the chapter 1 book in here, so you'll have to find page 102 and do those problems. And then I do have my answers on here. So as soon as you finish, go ahead and check your answers. You're not going to get points for this. You'll have formatives at some point in time. But for now, just go ahead and do that. And then here was the copy of your chart to fill in. Okay. And then this video will be linked in here as well. All right, great. Thank you very much.